Hello, Civil and Environmental Engineering 214 Geomatics. Dr. Ames here to talk to you about geoprocessing site selection, the Walmart problem. You have learned some basic geoprocessing tools so far, and for this presentation and the associated lab assignment, which for us this semester is lab assignment number 11, you will be finding an optimal place to put a Walmart in Utah County. And so I want to use this Walmart problem as a way to help you put together the big picture of geoprocessing to solve a real engineering problem. Before we do it, let's do a quick review of geoprocessing itself. Do you remember which of these are in fact geoprocessing tools? The answer, of course, is all of the above. Do you remember, if you were going to find all of the area near a school, which tool might you use to find all of the land area that's near a school? The answer, of course, is buffer, because you can make a buffer around a school, and that will show you all of the area around that school. Eliminating an area that doesn't satisfy your query or that doesn't meet the needs of your search, what kind of tool would you use to eliminate an area? Of course, the answer is erase, the erase tool. There are a few more interesting spatial analyses tools we can look at, such as Reclassify, I talked about in our last lecture. Here we're reclassifying wind speed to wind categories. So 1, 2, 3, 4, 5 miles an hour converted into classes of low or high. Notice this diagram here on the left, where we have wind speed as a data set being processed through a geoprocessing function, and then we draw the resulting data set again as wind class. Here's reclassify again. This time we're reclassifying polygons. We're taking population density in all of these small polygons, and then we're going to reclassify them from actual census data population density, which are probably in units of people per square mile or square kilometer. We're reclassifying those into population classes of sparse or dense. So reclassify, nice useful tool. Here is another one of those workflow diagrams where we take a data set, we run it through a geoprocessing function, we get another data set at the end. So think about this buffer we talked about last time. When you're buffering data, you can buffer points, lines, or polygons. There's not really a buffer function for raster data. Buffering is really only for polygon, point, or line data, so vector data. And regardless of the input data type, point, line, or polygon, the output type is always a polygon. And you can see the buffered polygons here. And notice that when these buffers were run, an option to dissolve the resulting features was used, so that even though the input on these lines is 1, 2, 3, 4, 5 lines, the output is a single polygon that shows the joint buffering of all of those lines, rather than 5 separate polygons. Let's look at the erase function. Do you remember erase? Erase, here we have the counties of some state, and we've got a catchment that happens to run in the middle of that state. That's a watershed boundary or a drainage area for a watershed with a river running down the middle of it. And for whatever reason, we've chosen to erase that watershed out of the counties. Perhaps we expect a big flood in that watershed, and we want to find the areas that will not be affected by that flood. So since it's an erase operation, we're subtracting out that watershed from the counties, and the result is, when you overlay and then you do the erase, the result is something like this. We have all the counties and the parts of counties that do not lie within that watershed. Which Boolean operation is like erase? Well, I said it a moment ago, the word is not. Counties, not catchment. And just a reminder, those pictures are taken from Paul Bolstad's book that we're using in this class. So credits to Paul Bolstad for those figures, and some of these additional figures we'll be showing. So let's look at this intersection, another common geoprocessing spatial analysis. Imagine that you have 2 data sets. This could be 2 different counties in blue, and then in yellow, let's say that's the buffered area around the place where you work. You're trying to find a place to live that's within a mile of your workplace. Well, you might want to intersect the 2 counties with the polygon of distances to work. And the result would be areas within those counties that lie within your proposed distance to your office and nothing else. So that is intersect. And as you look at this, what Boolean operation is this like? I haven't written it on the slide, but you should be able to tell this is like the AND Boolean operation. You're doing an AND between the input data set and the intersection features to come up with an output. Here's another AND. We're intersecting multiple polygons of catchments or watersheds with multiple polygons of counties. The result being a data set where we have small polygons that represent parts of counties and parts of watersheds, parts of counties and parts of watershed. For example, Dakota County and the Cannon River is included in this polygon at the bottom. Or up here in green, this is Anoka County and the Rum River. So there's another part of Anoka County, but it's a different watershed. And here's another part of Anoka County, but it's a different watershed. So again, that's Intersect, very useful tool. So let's go to this problem. Where would we put a new Walmart in Utah County? For whatever reason, we need to find, there's just never enough Walmarts, and we need another one in Utah County. So if you were to address this problem, you're the engineer hired by Walmart Corporation to solve this, you would have a lot of questions that you would want to examine and address to put into your design for this geoprocessing workflow to solve this problem. And you start with these kind of problems, almost always the question is, what are the conditions or the constraints that we need to be aware of in defining the location for the new Walmart, or whatever it is we're going to site select. You could be site selecting a new tennis shoe factory, you could do site selection for a home, a site selection for new housing development, a new skyscraper, a wastewater treatment facility, etc., an airport. But let's just do Walmart because it's a nice, simple, good place to start. So here's a new Walmart Supercenter. What are the conditions? Well, if we were in class right now, I would ask you, what do you think are the conditions? What are the constraints that define this question of where to put a new Walmart? Usually, some people would say things like, well, we don't want it near existing Walmarts. We should probably have it somewhere near there are a lot of families around, high density of families. We want it easily accessible, so it should be near a highway, for example. And then, of course, the constraint is that we want it in Utah County. Also, we need to make sure there's enough land mass. You think there are a lot of other constraints. Is there enough electrical power? Is there water nearby? Is it near a major Walmart distribution center so that we get the products shipped in? And so forth and so on. Actually, when they add, is it near a Target? Is it near a Shopco? And you can think about what kinds of constraints beyond these an actual GIS analyst or an engineer at Walmart would have to deal with in solving this problem. We'll just work on these four right now. So let's take those constraints or conditions and turn them into specific criteria, not too close to an existing Walmart. We do want it close to roads. We do want it close to families. Okay, so what are some of the input data we need and what tools do we need? Sorry for the typo, this should just say what tools do we need. Input data sets. Well, in order to solve these criteria, we must need locations of existing Walmarts. We're going to need a shapefile of Utah County because we said it's got to be inside Utah County. And we're going to need some kind of census blocks that have family and population densities. We can use that. And then roads. Major roads is something that you would have to define. What is a major road? A freeway, a highway, just a big road. What tools we're going to need? Well, all the same ones. It's select, intersect, buffer, erase, and so forth. And then finally, what is the workflow? We're going to want to try to draw a workflow diagram showing how to analyze this problem. So let's take the criteria and break it down a little bit farther, dig a little deeper. Proximity to Walmart locations. I said not too close to existing Walmarts. Well, how close is too close? Let's use 2 miles just for fun. Now, as if you're working for Walmart, you probably have a number that's better than us just throwing out 2 miles. I'm sure they have a number internally they use all the time. Proximity to major road. Well, what are we going to call a major road? Let's say I-15 is a major road or a highway is a major road. And we want to say, let's keep it within 2 miles of a major freeway or highway for access. In fact, I think that usually Walmarts are probably within a half a mile of existing major roads or freeway. We'll do 2 miles for the sake of argument. Population density. Well, we want it to be where there's a lot of population, high density, so it's easy for people to get to attract a large population to come to the store. So we'll take 2020 census data and let's make sure that the new Walmart is located in an area with over 2,000 people per square kilometer. It seems like a lot, but actually it's not that dense. But we could get that information from the census polygons. Now, a fourth criteria here is adequate space. Walmart stores are actually quite large and they require a very large landmass for the parking lots and everything. And so as a final step, once we've identified the locations around the county that meet our criteria, we could then actually zoom in and look at satellite images and other aerial images and identify locations that might have lots or parcels with enough space. So digging into the data question, where are we going to get a shapefile of Utah County? How about the Utah Automated Geographic Reference Center? Or if you're working in another state, you might use their state GIS website. A shapefile of roads and freeways could also be downloaded from AGRC. The Census District Map shapefile, readily available on the AGRC in the state of Utah, but also you can download this from nationalmap.gov because these are national data sets for the entire country. And then finally, current Walmart locations. This one's a little bit trickier. I'm going to have you digitize these. So you'll go into ArcGIS Pro, create a new blank shapefile of points, and then you're going to pull up Google Maps next to it, search for Walmart in Utah County, look at where they are here in Google Maps, and then come over here to your ArcGIS Pro and digitize or drop in points where those Walmarts exist. That way you can basically duplicate it. There's not a way to download those points directly from Google Maps that I know, and there's not a way to go to walmart.com and download it directly from them. So you'll have to effectively drop points on a map, looking at the Google Maps at the same time. Or if you just happen to know where all they are, that's fine. So you'll create a new blank shapefile called walmarts.shp and digitize those locations directly into it. And that'll give you all the data you need for this project. The tools that you will use will be like select. You'll have to select all of the roads that are I-15. Intersect, you're going to intersect data sets to find out places that are Utah County and are close enough to the I-15. Buffer, well, in order to get that 2-mile buffer around I-15, you'll need to use the buffer tool. In order to get a 2-mile buffer around Walmart, you'll need to use the buffer tool. Erase, we're going to erase out of the results areas that are too close to existing Walmarts. Dissolve, when you're doing buffer, it's good to dissolve the features together so that if you're buffering all these little sections of I-15, you don't end up with 100 different little polygons. It just dissolves them into one big polygon around I-15. Digitize is what you'll be using to digitize the areas of existing Walmarts, or the points of existing Walmarts, by looking at Google Maps and looking at ArcGIS Pro at the same time. And then calculating, we'll have to do a little bit of calculating in order to calculate population densities. So we were talking a little bit about geoprocessing workflows, and a geoprocessing workflow is basically a recipe for solving a problem. It's the way we do design work in geoprocessing and geoanalysis. We take input data layers and then we draw the analysis that's going to happen, then we make a box showing the output data set, the analysis is going to happen, the output data set there, the analysis that's going to happen, the final output layer. You can actually have 2 input layers going to a single analysis. For example, with intersect, you might have 2 coming in. Buffer or select would only have 1 data set coming in. Let's actually try solving this problem. Here's Utah County. Here are u.routes downloaded from AGRC. Let's select from u.routes everything that is I-15. So we'll select from u.routes where the route name is 0015. And that gives us that blue line in the middle. Now let's run a buffer. Here I did not do the dissolve. I should have dissolved them. Now I've got all these little circles around sections of I-15. If I'd used dissolve, I'd have one big polygon around it. Here are current Walmarts. I digitized these using Google Maps as a reference. And now we're going to buffer them. So we've buffered them all, and now we've got census blocks. Also, these are little census blocks. If you zoom in, each one of these is a polygon, and that polygon tells you how, information about people that live within that spot. We're going to try to draw a workflow of all of this, and here's the final picture. Finding this Walmart, these red circles, so in the ArcGIS, this is the ArcGIS view. The ArcGIS view uses ovals for data and rectangles for processing. So here we're selecting out the county. We've got Utah County. We're intersecting that with the roads just to get the roads in the county. And then from the roads in the county, we're going to come down here, select just the highways or the I-15s. We'll buffer them. And now you've got the buffered polygons, dissolve them all together. We're going to intersect them with the stuff we got here from the county census. And from that gives us areas that meet the census requirement and the road requirement. We're going to erase out the Walmart polygons out of that to find the possible locations. And at the end, here's a map of what it might look like. So good luck with your lab assignment this week. You can do it.